A very good afternoon to all. Today I'm going to start the direct metal laser symmetry. Okay, this is a direct method of the rapid prototyping. Last lecture in the yesterday lecture we have seen indirect method, and indirect method we have seen one of the type that is called the soft tooling. This is comes under the dark. This is comes under the hard tooling. Okay, that is called the direct metal laser symmetry. In the soft tooling we are using any soft material like a rubber and wax and such kind of material, but in case of a hard tooling and direct laser symmetry we are using a different types of metal. You can see over there like a nickel as well as the bronze. Okay, some hard material also. A laser beam is used to sinter the material selectively to manufacture the core and cavity insert directly from the CAD data. Okay, means first we have to make the model in the any CAD software, and after the CAD software we can give an input into the machine, and from the machine it will be forming any kind of a die cavity, and from that die and cavity we develop the different types of material. But in this case a die and cavity always made by the material that is called metal, that is a nickel and bronze. This technique is a layer additive technique. As already we know, this is a layer additive technique, layer additive type of manufacturing. This insert after they have been made on the machine can be directly put on the modeling machine after desiring level of policy. The basic principle is that the initially the CAD data is sliced. Sliced means that is called the layer by layer by the rapid prototyping software, and then each slice layer is sintered by the laser beam in the XY direction. After one layer is complete, the build platform moved by a predetermined layer thickness, usually 0.1 mm. Means the same principle here also they are working, as we have seen in the different types of processes in the rapid prototyping, that one layer has been formed, then platform goes down, and then again the another layer will form. Okay, so they same principle here also they are working. Then the second layer is cured or it, and this way the entire prototype is built up by the subsequent joining of the layer. The tool life obtained from the technique is comfortably 500 pieces. Okay, the tool which is developed by the direct metal laser sintering, and that having the material is nickel and bronze, and that can be used to the 50,000 pieces. We can manufacture the or fabricate the 50,000 pieces from that process. Okay, so this is like the direct metal sintering. I'm having the few videos, and by the videos your concept is more clear that how this process is takes place. You concentrate towards this video so that your concept is more
Direct
clear.
metal laser sintering, also known as DMLS, is an additive manufacturing technology that creates metal parts directly from 3D CAD data without the need for tooling. DMLS utilizes a variety of metal and alloy materials
Different types
such
of
as
metal we
stainless
are
steel,
using in this case to
cobalt
develop
chrome, and Inconel to create strong, durable
Cool.
parts and prototypes. DMLS is an excellent choice for functional metal prototypes, high-temperature applications, and end-use parts. Direct metal laser sintering, also known as DMLS, is an additive manufacturing technology that creates metal parts directly from 3D CAD data without the need for tooling. DMLS utilizes a variety of metal and alloy materials such as stainless steel, cobalt chrome, and Inconel to create strong, durable parts and prototypes. DMLS is an excellent choice for functional metal prototypes, high-temperature applications, and end-use parts. The DMLS process begins in the same fashion as other layer additive manufacturing technologies. A program takes 3D CAD data and mathematically slices it into 2D cross-sections. Each of these sections will act as a blueprint, telling the DMLS machine exactly where to sinter the metal material. The data is then transferred to the DMLS equipment. A recoater assembly pushes powdered metal material from the powder supply to create a uniform layer over the base plate. A laser then draws a 2D cross-section on the surface of the build material, heating and fusing the material. Once a single layer is complete, the base plate is lowered just enough to make room for the next layer. More material is raised from the cartridge and recoated evenly upon the previously sintered layer. The DMLS machine continues to sinter layer upon layer, building from the bottom up. As the part is built, support structures are added to give supplemental strength to fine features and overhanging surfaces. The completed part is then removed from the base plate and treated with an age-hardening heat process to further harden the part. Any support structures are also removed at this time. With numerous surface treatment and hand polishing options available through service providers such as Solid Concepts, DMLS parts can be used in highly cosmetic applications. Typical uses for DMLS include tools and manufacturing aids, small integrated structures, dental components, surgical implants, and aerospace parts.
So you have seen like a different types of a metal we can generate over here by use of this. Just a minute. And we have developed like a number of model, okay, and you can see the another one more video is there, okay, and by this video also you will be understood how the number of part we can develop at a time. But you have seen in the like a different types of process or different types of commercial use, different types of method of RP, there only we can develop one more part, but here we can develop like a multi part, okay. So there is another video over here.
Your challenge? To produce in series a product in metal with inner structures, undercuts, and serial numbering. EOS has the right solutions for you. Direct part. Without any additional steps, you can manufacture complete, fully functioning metal parts with the laser sintering system EOSint M directly from electronic data. Innovative laser sintering technology creates the desired product, layer by layer, using only powder-based metals and laser energy. This is EOSint M, the worldwide leading system for direct production of high-grade metal parts. Use it also to produce tooling inserts for die cast.
You can see over here like this is a number of part we can develop, okay. It is not the single, it is number of part we can develop by use of this method, and this is the only method. In this case we are using the metal. Other than you can see the other method are there, but in all the method you are not using any kind of a metal material, but here we are using the metal, and number of part we can develop by this method.
Direct pattern. Using the laser sintering system EOSint P, you can create lost patterns from electronic data. With subsequent plaster investment casting, for example, you can create the finished metal part in the original material.
This video is visible to all? Saurabh?
Direct cast. Using the laser sintering system EOSint S, you can produce highly complex casting cores and molds without mold draft angles, which gives you the finished metal part in the original material. Freedom of design is almost unlimited. Be it the knee implant built using the direct part process, or the gearbox produced by the direct pattern process. E-manufacturing solutions from EOS. Fast, flexible, and cost-effective production directly from electronic data. Think the impossible. You can get it.
Then you have seen like a different types of metal, like a engine part, a block, side covering, and whatever the metal parts we required. Nowadays, in the many automotive industry as well as like aero industry, developed different types of metal part from the direct metal laser symmetry, and it is too easy. Okay, and it is like a defect free, error free. Hence, this method is very popular comparing to the other method, because this method is basically used for the metal manufacturing of the different prototype. So this is very important, you have to know. Okay, is there anyone having any kind with the application of the rapid prototyping model? There are the different types of application of the rapid prototyping. I am having few beautiful images also, so that it will be like more attractive to you all and you will be enjoyed. Okay, you can see are totally surprised in a medical application. This is one of the example of the medical application. Mostly prototype rapid prototyping always used to develop a different types of bone. Human being having the more or less like a 200 bones. Okay, if the some bone is damaged, and we need to develop that bone, like by use of any die casting, it will take a time, but by you as well as the accuracy and functionality is not that much good. But if we develop by use of rapid prototyping, that is very easily we can develop within a very short amount of time, because in case of medical emergency we required any kind of part, any kind of bone within a very short amount of time. Okay, so here you can see in the first figure. Okay, the some bone skull front side of the, or it is a part of the skull, some bone of over here is damaged. Okay, some bone is damaged, you can see over here. Okay, some bone is damaged, and I want to make this bone by use of rapid prototyping. Okay, and after that you can see like a figure, it does not look like, and it is having the very good strength also. The strength of this part is also very good. Okay, like that, if someone any bone of the body is damaged, we can develop by use of rapid prototyping. Okay, so this is one of the example of the medical applications. Next, we are having the electrical applications. You can see different types of glowing instrument are there. Okay, this, 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 and this also, this also, this also. The different types of glowing instrument are there, and this all glowing instrument we can develop by use of rapid prototyping, and it is really a very beautiful. Okay, you can develop and you can manufacture and fabricate by use of rapid prototyping. This is called the electrical application. So this is nowadays very fastly we can develop by use of rapid prototyping, and in a many interior designer use this kind of appliances for the beautiful home. Okay, so this is the example of the electrical appliances in a footwear design. Okay, a very complex foot. Okay, you can see the strength of this part. Okay, it is very important, because in case of high heel sandal, that is preferably used by the many women, they always design a different types of component, but it is very difficult to develop by use of any kind of die. By use of rapid prototyping, we can easily develop this kind of model. Okay, and that having the very good strength also. You can see this model also. Okay, you can see that this model also. Okay, this is a footwear design. This is one of the example, but the more and more complex part also, which is not possible by use of die casting, we can develop by use of rapid prototyping. Okay, next we are having the furniture design. Okay, and different types of furniture you can see over here. This furniture, this kind of furniture, and a cupboard, and the different kinds of furniture we can develop by use of rapid prototyping. Okay, and this is like a very beautiful by the fabricated method, and by the other method it is very difficult to develop this kind of beautiful furniture, but this is only possible by use of RP. So you have to develop this kind of furniture by use of Ravi prototyping. This is also the one of the example of the Ravi prototyping. Architectural interior design. Okay, as already we discussed in the, this all are the instrumental electrical instrument we develop. Here also we are develop the different types of architectural interior design. You can see. Okay, this part, and this part. As well as nowadays in the civil engineering also, as already you heard about the news, in the Dubai they have developed like a whole building by use of Revit prototyping. I don't have a figure over here. I'll show you in the direct internet after this slide. Okay, but building and the different types of different types of Revit prototyping, they have developed like a whole building. Okay, I'll show you. Design of the special object. You can see this object is very difficult, and this is also very difficult to manufacture. Okay, but this is some special part of the object you can develop. Okay, a part developed by use of Revit prototyping. So this is like some special examples. Okay, in Dubai they developed rapid prototyping. See here, world largest 3D printer building complete in Dubai. See, this is the building that is developed by 3D printer.